welcome to the webinar today from Fire Middle East. It's been sponsored by Potter Global, which is a company that is long established, been in the marketplace since 1898. See, I've done my research, and it was started by Charles Potter. And one of the things that he started with is probably very dear to my heart, in that it was about allowing signals to be transmitted to the emergency services so they could attend the incidences that they were required to attend. So the fire, the police and the ambulance. So again, that's the first innovation that he brought into the marketplace. So you can see they're over 100 years old and developed a very strong reputation in the field. And one of their driving things is they want to bring their marketplace experience, but bring it with authenticity, so that they work in partnership with their clients to give their clients confidence and to support them to deliver the highest quality result. They've evolved into different areas of the marketplace, moving to fire and life safety in 1982 again, and they've focused heavily into that marketplace as they've gone forwards, and building their brand reach by acquiring several different companies in recent history. So our presentation today is going to be delivered by Ali Baghdadi, and it's on Beyond the Alarm. Now, for me, as an old firefighter, this is something that I'm really passionate about, and he'll take us through what is a really interesting concept, interesting presentation. So you could go away with education about human behavior and understanding the benefits of using a voice system as opposed to just the standard alarms that we have. So I'm looking at Ali to see if he's ready, and I'm going to hand over to Ali. Otherwise, I can talk for everybody, and I can talk for the hour without even letting Ali get on the stage. So please, we've other people in the background, Ahmed Sultan and Bavia Chemban, who are here to assist us as we go forward. So over to you, Ali.
Thank you, Bob. Good afternoon, everyone. Thank you for Fire Middle East for hosting today's webinar. My name is Ali Baghdadi. I'm the Regional Sales Manager for Saudi Arabia at Potter Global Technologies. To be honest, it's a pleasure and an honor to be presenting today's topic to such a respected group of industry professionals. So thank you all for taking the time to be with us today. So as Bob said, today's session is called Beyond the Alarm, and the title, to be honest, is intentional. For many years now, the primary expectation of a fire alarm system was simply to alert occupants that something was wrong. However, in modern high-rise and mixed-use buildings, that is no longer enough. Occupants need clear, timely information. Buildings operator need greater visibility and control. Emergency responders need systems that support coordinated decision-making and efficient incident management. So this session is designed to be educational and application-focused. We will discuss why traditional alarm-only notification can maybe fall short in tall buildings, how voice evacuation enhances occupant communication, and the key design and operation consideration for implementing these systems effectively. Toward the end of the session, we will be briefly demonstrating how these principles are supported by actual modern fire alarm and voice evacuation technologies. Now, to understand why voice evacuation has become such an important topic, let's first look at how modern buildings actually evolved. So across the Middle East, modern developments are no longer simple towers with one occupancy, one operating model. A single high-rise can include residential apartments, hotel floors, offices, retail areas, restaurants, parking levels, and sometimes public spaces. In practice, this means one building may contain multiple populations with very different needs. A resident may know the building very well. A hotel guest may not know the nearest stairwell. A retail visitor may not know which part of the building is affected. Staff should be trained, while visitors are not. Some occupants may need assistance, and some areas may need to remain operational while others evacuate. So, this is the first reason voice evacuation matters. In complex building, the problem is not simply detecting a fire. The problem is communicating the right instruction to the right group of people at the right time. So, as building changes, the role of fire alarm system had to change as well. We'll see how. So, fire alarm system did not evolve simply because technology became available. They evolved because expectation changed. In smaller or simple buildings, maybe an audible alarm may be sufficient to start evacuation. But as building became taller, as mentioned, denser and more mixed use, the evacuation challenges changed. We need to know where the event was located, which floor or zones were affected, which occupants should move first, and what instruction should be given. That evolution moved the industry from manual bells, then to conventional fire alarms, then to addressable system, and now to something called integrated emergency communication systems. The modern expectation is no longer just make noise. The expectation is detect the event, identify the affected area, communicate appropriate instructions, and support a controlled response. This actually leads to a practical question. If the building and expectation changed, is ringing a bell still enough? So traditional alarm notification is very effective at one thing. It gets attention, to be honest. But getting attention is not the same as giving instruction. So, like said, when occupants hear a tone or horn, they know that something may be wrong, but they may not know where the emergency is, whether they are in the affected area, which exit route is preferred, or whether the safest instruction is to evacuate immediately or maybe wait for further direction. So the voice evacuation adds that missing layer of communication. It allows the system or operator to deliver a message such as a fire has been reported. Occupants on level 21 through 23 should evacuate using the nearest stairwell. Occupants on other floor should remain alert and await further instructions. That type of message changes the response. It reduces uncertainty, support phased evacuation, and actually helps occupants make better decisions under pressure. Applicable example, in a shopping mall or hotel, an alarm tone alone may cause confusion. A clear voice message can direct occupants to the correct exit route and reduce unnecessary movement towards affected areas. And to fully understand why this matters, we need to look at the human side of evacuation. The most important point in this section is that buildings do not evacuate themselves. In the end, people evacuate. And people do not always react exactly as designers expect. In evacuation research, there is a concept called pre-evacuation time. This is the period between the first cue, such as an alarm, smell of smoke, or instruction from staff, and the moment the occupant actually starts to move. During this period, occupants often interpret the situation, look for confirmation, observe others, ask questions, maybe collect belongings or continue working, or wait for more information simply. This can happen even when the alarm is clearly audible. Voice evacuation helps here because it provides credible information immediately. It tells occupants what is happening, who needs to move, where they should go, and whether they should wait for further instruction or not. In a high-rise building, that clarity can support a more orderly and controlled response. Now, we established the problem. Complex building, limited information from alarm-only notification, and also really human response behavior. We can now introduce the solution, voice evacuation as a structured communication strategy. This is where we formally introduce voice evacuation. The key point here is simple. Voice evacuation is not about making the system louder. It is actually about making the emergency response clearer. A traditional alarm tone can alert occupants that something has happened, like we mentioned, but does not explain what action is actually expected. A voice evacuation system can deliver pre-recorded messages, automatic instruction, and also very important live announcement to selected areas of a building. For a high-rise, this matters because the safest action may not be identical or is not identical actually for every person in the building. The occupants on the fire floor may need to leave immediately, while occupants in other areas may need to prepare but remain in place or just wait for further instruction from an emergency responder. And once we understand that voice evacuation is about guidance, the next question is, what makes actually a voice message effective? So voice evacuation is only effective when the message is well designed. A poor message can create confusion, while a clear message can support a faster and more orderly response. For a mixed use, what I recommend is explaining the emergency messages through three simple qualities. It should be clear, credible, and practical. Clear means the language is simple. The announcement is not too long. It avoids technical terms. Credible means the message sounds authoritative and consistent with what occupants are seeing or hearing. And the practicals means the message tells people what to do next, if evacuate, relocate, remain in place, or use a specific route, or just wait for further instructions. This actually aligns exactly with the human behavior research, showing that people often seek confirmation and additional information before they take protective action. And a properly designed voice message help reduce that uncertainty. And now that we have the message, we need to decide who receives it. That leads us to something called phased evacuation. So this slide answers a question many, maybe non-specific specialists ask. Why not simply evacuate everyone? Actually, in low-rise buildings, simultaneous evacuation may be practical, but in tall buildings and complex environments, and mixed-use development specifically, evacuating everyone at once can create heavy stair congestion and operational challenges. So phase evacuation allows the response to prioritize the area of greater risk. For example, the fire floor and adjacent floor may receive immediate evacuation instruction, while more remote floors, as mentioned before, receive standby or preparation messages. So the exact strategy must follow the applicable building code, fire strategy, authority requirements, and project-specific fire engineering approach. The purpose here is not to prescribe one universal sequence, but to show the value of selective communication. And once different floors may receive different messages, the building must be divided then into meaningful communication zones. Let's see how. So, mentioned previously, the modern high-rise buildings often contains very different occupants group, right? So a hotel guest, an office tenant, a retail visitor, a resident, a maintenance contractor maybe, and surely the security officer. Do not all have the same familiarity with the building. They must also be in a very different physical environment. This is why zoning is very important. Zoning is something treated as a technical design task, but it is also an operational life safety decision. The question is not only how many speaker circuits we need. The deeper question is who needs to hear which message during which scenario. For example, a hotel guest may need very simple instruction, while trained staff may need operational messages. Public areas may require broader and more repetitive instruction, while back of house areas may need staff-specific guidance. And with multiple zones and occupancy group, the system also needs something called a hierarchy of automation and manual control. and it should be clear. So a strong voice evacuation strategy does not rely only on automation or only on manual paging. It actually uses both. Automatic messages are very valuable, surely, because they are fast and consistent and can be initiated immediately upon a confirmed alarm input or defined event. This actually helps avoid silence during the early moment of an incident. But also, live paging is equally important because real incidents can change. A stairwell may become unavailable, smoke conditions may change, emergency responders may need to redirect occupants, or staff may need to give instructions that were not part of the original scenario. So the design question is therefore not automatic versus manual. The question is how the system prioritizes messages, who is authorized to take control, and how those procedures are documented, tested, and understood by the building team. In the next session and the next section, we will look at the message quality, software-driven operation, and design coordination, and the practical lessons that help these systems succeed in actual real projects. So again, when people think about voice evacuation, they often think first about speakers, amplifiers. So those components truly matter, but the real objective is not simply volume. The objective is understanding. A system succeeds when the message is audible, simple, relevant, and credible. Audible, as mentioned, means the occupants can hear it. Simple means they can understand the words. Relevant means the message applies to their zone or situation. And credible means it sounds like an official instruction, not just a background noise or casual announcement. And in a real incident, the message should be short, direct, and action-oriented. It should tell occupants who the message is for, what happened at a high level, and what they should do next. To be honest, a poor message through an excellent system is still a poor communication emergency strategy. So, and once messages are clear, the next question is what happens when the situation changes? In the end, voice evacuation is not only about playing a recorded message. In a real high-rise emergency, conditions can and will change quickly, unfortunately. A system should therefore support both automatic response and live command. The automatic messages are valuable because, like mentioned, they are fast and consistent. When a detector or manual police station activates in a defined zone, the system can immediately play the correct message to the exact affected floor or areas. This actually helps to reduce the delay between detection and occupant instruction. But in the end, automation alone is not enough. Security teams, fire command staff, or emergency responder may need to provide updated instructions based on smoke conditions, block routes, false alarm confirmation, or simply changing tactical decisions. So a well-designed system allows authorized personnel to override automatic messages, target specific zone, and update instruction as the situation develops. Priority logic is essential, so emergency announcement override routing, paging, or background functions. The next layer is how software-driven configuration helps manage all these scenarios without making the operation unnecessarily complicated. So modern voice evacuation systems are increasingly software-driven. This is an advantage because software allows a flexible zoning, messages selection, priorities, event logic, and operator visibility. However, software does not replace the actual fire strategy. It implements it. It implements the fire strategy. So, and that distinction is very important because before programming begins, the project team should understand the evacuation philosophy. Which areas evacuate first? Which areas received alert messages? Which door stairs or route are preferred, how the fire command center will actually operate, and what the AHGs expect. Only after that should the system logic be programmed. The cause and effect matrix should map alarm input to voice output in a way that matches the approved virus strategy. The message library should be controlled, priority logic should be clear, and operators should be able to see what is active and understand what they are allowed to control. In short, software-driven systems simplify complexity when the strategy is clear. If the strategy is unclear, even the best software can simply automate confusion. That brings us to a key best practice. Design should begin with a strategy, not equipment selection, and we will see how. So, one of the strongest lessons from high-rise project is that voice evacuation should be considered very early. It should not be treated as a speaker quantity exercise at the end of the design. The right starting point, to be totally honest, is the building profile. With what occupancy are present, maybe how tall at the building, what are the stairs, is there a fire command center, are there refugee areas or special use zones? And then the next step is the evacuation philosophy. Is the building expected to use total evacuation, maybe phased evacuation or stage evacuation, sometimes defend in place for certain occupancies, or maybe a hybrid approach? So different buildings require different strategies. The third step is communication zoning. Now, the speaker zones should make operational sense. They should align with floors, smoke compartment, fire zones, and functional areas where possible. Next is the message strategy. What automatic messages are required? Who approved them? How are live messages controlled? And then the last step is reliability. Pathway survivability, backup power, supervision, testing, maintenance, and even training. So after strategy comes reliability. A communication system must continue to operate when the building is under stress. So as mentioned, the final point in this section is reliability. In emergency communication, reliability is not a single product feature. It is a system attribute created by the complete chain. The system needs suitable primary and standby power. Communication pathways need to be protected or survivable, where required by the applicable code and evacuation strategy, surely. Faults may be supervised, so they are visible before the emergency, not discovered during it. Operators need clear command authority, and the system must prioritize emergency communication over non-emergency function. Testing is also very essential. It is not enough to confirm that speakers make sound. Teams should verify that the correct zones receive the correct messages, and that the messages are understandable, and that the operators, this is the most important point, the operators know how to intervene. So for high-rise buildings, some of the most important lessons are practical. Just coordinate early. Keep zoning logical. Make messages clear. Avoid overcomplicated control sequence. And train the message and the people who will actually use the system. With these best practices established, we can now look at how modern integrated fire and voice platform supports these principles. So at this point of the presentation, we move from the concept of voice evacuation to the actual practical lesson learned from a real project. So the evacuation strategy must be designed before the hardware is finalized, like that. For a high-rise building, it is not enough to ask how many speakers, how many amplifiers, or how many circuits are required. Those are important engineering outputs, but they should come after the evacuation logic is clear. The more important question is, like mentioned, who needs to hear which message and at what stage of the incident and why, what to do. This is where early coordination becomes essential. Fire protection engineers, MEP consultant, architect, operation teams, contractors, and authority having jurisdiction all need a shared understanding of the intended emergency response. A voice message or a voice system can only support phase evacuation effectively if the zones, messages, priorities, operators control, and even testing procedure are all aligned. A useful practical tool is something we call a message matrix. It defines the scenario, the affected area, the evacuation area, the alert area, the message to be played, and the priority level, and whether the operator intervention is expected or needed. This avoids ambiguity during commissioning and actual handover. So the key message is simple. Voice evacuation is not only a device selection exercise, it is an emergency communication strategy supported by technology. So now that we have defined what good design requires, let us look on how modern integrated platform supports that strategy in practice. Okay, so once the evacuation strategy is defined, the next question becomes how do we implement it reliably and simply? As mentioned, modern integrated platforms are important because they bring together detection, decision logic, messages, operator controls, live paging, speaker zones controls within a coordinated life safety system. This is very different from treating the fire alarm system and the voice system as completely separate layers that only meet maybe at the end of the project. The practical benefit is clarity. When the fire alarm panel identifies the event, the system can automatically activate the correct message for the correct zones. If the incident develops, a trained operator or responder can use live paging and manual controls, as mentioned previously, to adapt the instruction. This supports the principle we have discussed throughout the webinar, not simply alerting the occupants, but actual communicating with them in a controlled, targeted, and understandable way. To be honest, this is where Potter's integrated voice approach becomes relevant. The objective is not just to add speakers to a building. The objective is to support the emergency communication strategy through a platform that combines fire alarm operation and voice evacuation functionality. Let us just have a look at one of the most important differentiators in modern system, which is software-driven messaging and operation. So one of the major trends in emergency communication is the move towards software-driven operation. This does not mean making the system casual or uncontrolled. It means making the process of creating, assigning, testing, and maintaining emergency messages more efficient and more repeatable. In traditional project, creating voice messages could require external recording, third-party audio tools maybe, and repeated coordination, surely, whenever the message needed to be adjusted. But Potter platform can reduce that friction. Actually, Potter integrated voice systems includes capability such as something called WaveNet text-to-speech, which is a text-to-speech feature. Also includes predefined messages and tones, the ability to record and import message files, customizable audio patterns, and very, very much flexible programming. The purpose of these features is not technology for its own sake. The purpose is just to help the project team implement the approved evacuation strategy, but more efficiently and consistently. And surely it is important to add one professional note that the emergency messages and evacuation logic should never be changed informally. Any change should follow the project's approval process, surely, be coordinated with the responsible consultant or authority, and be tested before handover or operation of the system. So the differentiator here is not simply that messages can be created through software. The real differentiator is that software can help simplify a very complex life safety workflow while maintaining control and documentation. And to be honest, software is one side of the story. Large buildings also require capacity, scalability, and network operation. For modern high-rise and large mixed-use development, scalability is not just about the product capacity. It is about whether the system architecture can support the evacuation strategy as the building grows in complexity, like mentioned. A project may require many addressable devices, multiple evacuation zones, several amplifier locations, remote microphone locations, and coordinated paging across large areas. This is where platform capacity and network architecture becomes important. Our Potter IPA 4000 platform supports up to 4064 addressable points per panel and a scalable voice evacuation system with up to 104 programmable push button, 31 system amplifier, and 248 speaker circuits. And also, the very important point to point out, the multiple panels can also be networked together using Potter integrated voice, network paging, so delivering seamless voice communication across very large and complex facilities. For operation and maintenance, Potter IP-enabled platforms can also support reporting, event email, remote visibility feature, which can help facility teams and service provider respond proactively, not after the issue occurs. So the professional message here is important. Capacity numbers are helpful, but the final design must always be based on the project requirement. Applicable codes, equipment listing, authority requirements, detail engineering. And gents, in the final slide, we will just summarize the principle that matter most for any modern high-rise voice evacuation strategy. So to conclude, the central message of this webinar is that modern high-rise building may need actually more than alarm notification. They need emergency communication. First, occupants need clear instruction. A tone or strobe can alert people, but it does not explain what action they should take. Second, the voice evacuation system must be designed around the virus strategy, not after it. The technology should support the approved evacuation philosophy, not define it after the fact. Third, phased and staged evacuation must be carefully planned. The purpose is to reduce unnecessary movement, avoid congestion, and prioritize the occupants who need to act first. Then the system must remain in operation during a real event. That means live paging, operator controls, clearly defined priorities, commissioning tests, user training. All of these are part of the life safety outcome. And finally, technology should simplify complexity. So software-driven platforms can make it easier to manage messages, zones, patterns, reporting, and future changes, provided that these changes remain controlled, tested, and documented. So thank you again to Fire Middle East and to everyone in the audience for your attention. Bob, I'll hand it back to you. And if we have time, I would be happy to answer any question from the audience.
Yeah, I see that Mark has just reminded people that we're open to take questions. Very thought-provoking, Ali. Much appreciated, and thank you for the delivery. Very clear and concise, and for me, as we said before we started, you know, I'm an old firefighter, so I look at things slightly differently. And for me, what was interesting was where you showed the high-rise evacuation strategies that we tend to employ with our high-rise approach to fires. And what that does for me is it shows that you're thinking about lending the information and supporting the civil defence in the way they align that way, which is a really valuable a valuable asset of the system. And I say that because as an incident commander, one of the key things I'm looking for where is the fire, where's the seat of the incident, and where are people. And if you can give me the information to say that we've used our evacuation strategy and we've evacuated floors 21, 22, and 20. 20 is the fire floor, then that helps me focus what I'm going to do. One of the highlights for me also is the fact that you have the ability to interject and override it manually and put a manual message through either by text or by the spoken word, again, because that again allows, this is my concept, allows you to adapt the system to the situation in front of you, because the situation never behaves itself when it's a fire. It will never do exactly what you're looking at. So
Exactly.
there's a couple of questions come up in the Q&A section, but I don't know whether you've got anything that you want to come back on there while I quickly read the questions. So Jason's come up with, it says, thanks for the presentation. Alongside the PAVA system, are you also seeing a requirement for refuge systems? Really good point, Jason. And again, I think that's something that Ali may have an idea about.
To be honest, this is an important question, but it actually relates to the actual structure of the project. Again, if the refugee system would help a lot in a certain building structure and occupants' presence. But to be totally honest, sometimes, like we said, in smaller buildings and less complex environment, maybe even a fire alarm is enough. So we cannot actually answer this, the requirement for the refugee system in general, that it is needed everywhere. It is needed, it is very important, but in a certain environment more than others.
Yeah, I think I see where Jason's coming from with regards to refuges, and again, from my perspective as an old firefighter, the ability to communicate with people when they're under duress, to try and calm them and keep them in position is really valuable. As you say, yes, you can do it, and but it works with a building strategy, obviously. So that's really important. Diala has asked, could you please explain what should be the strategy adopted for voice alarm systems in buildings that have large atriums or large buildings such as airports? And should any alarm zone coincide with smoke control or sprinkler zones?
So surely, to be honest, the more complicated and complex the environment is, the more intervention or correlation between the fire strategy, cause and effect matrix, if it is from alarm zones and smoke control, sprinkler, or even just elevators or everything else interface to the fire alarm. So the more complex the environment, the more correlation it should be reflected into choosing what are the evacuation zones. Let's say in an airport, the rescue or directing the people to go from a specific route is more complicated than simply in a building where you have only 2 stairways or 1 exit stairwell to go from. In a building, it's more or less easy to say that the floor that have alarm in it and above 2 floors, below 2 floors should evacuate now. The egress plan that it can, the stairwell itself can contain this number of people. But in an airport and more horizontal structured building, maybe live paging and intervention of the operators and the live control is very, very more essential, because it will orient the group of people upon their live now occupancy to go from a specific route from another. So it should consider also the smoke control or sprinkler zone, maybe smoke control more than sprinklers, but everything it will be taken into consideration when choosing the emergency zone, the evacuation zones.
Yeah, again, to support what Ali's saying is that any building of that nature will have had an emergency response plan put together. And within that emergency response plan, what they will have is a training element and the staffing element. So to support the evacuation, to help guide people, you would expect some of the staff to become more visible, whether it's using a high visibility jacket or just being positioned to help move people into the right areas. And that kind of leads into Mohammed's question as well, where he asks a lot more about human behavior under emergency situations. And with human behavior, again, what we need to consider is the fact that people don't behave as they normally would. They don't have the same thought processes as they normally would. Not a criticism at all, because it's something outside the norm and they
It's
don't
common.
react as, yeah, and so they don't react. So this is where the spoken word is much more effective at directing people, provide the message is delivered in the right format. So what Mohammed asks is, during a real emergency, occupants may ignore the announced evacuation route if they believe another route is safer, and others may follow them. How do modern evacuation strategies account for this human behavior, and how can designs reduce its impact on the evacuation flow? I'm going to answer just quickly before you jump in,
Yeah,
Ali.
sure,
So,
sure,
so,
sure.
so, so just pause a second. Again, it kind of lends into what I said just now. If you think about the emergency response plan that is designed as the building, if you work your fire strategy out right from the beginning, and operations is considered as part of the design process for the building, then what you see is that ability to build the team and factor in those vagaries when someone thinks, "Oh, I know better." And by having highly visible people in and around the evacuation routes, it helps corral people the way you want them to go. Now, obviously, you need to think about your staff and your occupiers' safety alongside that. But I'm going to move back to Ali now. But again, for me, it's all part and parcel of the emergency response plan.
Yeah, exactly, exactly. I mean, it's always routing back to that. How can design reduce its impact? But as mentioned, simply just do it early. The early involvement of the evacuation system in the design stage is really important. Just imagine the human considering which route to go. He will go to the easiest route from him to the route maybe illuminating. We have something supporting this as the central battery or emergency lighting system. It helps routing you to the exit stairs where you should go. There is an exit sign. It's already illuminated even if you have emergency cut off power. So everything, to be honest, should be considered together. So you will see two stairs across different parts of the level. So it makes actually the evacuation strategy and evacuation plan to be near what the human are easy to do. Okay, are more easy to do. So how can they reduce the impact? The impact is there, like we mentioned. This is a human behavior, but as soon as possible that this emergency consideration can be done, it is the better.
Yeah, and again, I think when you mentioned earlier on about staircase capacities as well, one of the reasons the emergency response plan and the fire strategy is worked out right at the beginning is the potential loss of one of those staircases, and it kind of lends into Diala's second question in about total evacuation of a building as an atrium. I'm going to come back to Jason's stuff in a minute, so I don't think I've forgotten Jason. Um, but it's very much about, you have to factor in the need to evacuate gently again, because not only you've got the people coming out, you've got the fire service coming in. So we need to have a flow and a counterflow. And it might be that looking at how we work our evacuation strategy, we may be looking to evacuate in one staircase and use egress for the fire service in the second staircase. But it may be you've lost a staircase altogether because people don't understand the passive protection that's built into the building, and they've compromised it. So the products of combustion have entered that staircase, the pressurization has failed, etc., etc. Lots of different things that could come into that. But it's very much about, when you occupy the premises, training, training, training. And what we need to also do is train our residents and our occupants, not just the staff, so they understand what these messages that are being transmitted mean. So now if we have a intermittent alarm or a solid alarm, does that mean that we evacuate, or does it mean we stay in place? With a voice alarm, we have to do the same. And as Ali was saying early on, when you have the like floors, these 3 floors, please evacuate. Other floors, stay, wait, and listen. We'll advise you what's going on accordingly. I think that helps that point there. Phased evacuation in high-rise buildings is an essential, or is a proven evacuation strategy, because it allows the staircase capacity to accommodate the flow. If we try to evacuate everybody at one time, you could wind up with 1,000 people trying to occupy a staircase that's only been designed to take 400, because of the amount of people that can then traverse that distance in a set period of time, which is the evacuation time. Sorry, I'm going off on fire safety, so forgive me. I told you I was able to talk for Britain. So I'll hand back to Ali, because I can see him nodding in agreement. But
No, no,
Diana,
no.
if that hasn't answered your question, then please come back to me.
Couldn't agree more. Actually, this is the essential strategy to apply for specifically for a high rise and maybe atrium buildings. The thing is, as mentioned in the presentation, like fire protection system, let's say the fire suppression or the water system or whatsoever, all these systems, the effectiveness of them is by the system itself. So if the system protects the area, it must be that the system is effective by itself. Here in evacuation, it's truly related also to the human behavior. Like we mentioned, the people evacuates. The system itself just orient the people how to evacuate. So when we do apply phased evacuation or stage evacuation, it's because we don't want to make confusion. We don't make to put more than the capacity that is the maximum capacity that a staircase, let's say, can adopt. So this is why phase evacuation is essential and very important to do here. You will just orient these people. Now, please, this group of people go. Another group of people, please be alerted and just stay in place. And for them to properly do an effective evacuation plan.
It does rely on discipline, and in order to get discipline, we need to train. And I think that's a key element that comes on the back of it, and that comes from an old firefighter, that has seen the rough end of it, as well as the theory end of it as well. So, and I think what this lends into, and it captures basically what Jason was saying, it's about egressability. And it's a word that he's put in the Q&A section. And again, egressability is about people getting in and out and the movement around, but it's a safe movement throughout a building that we're looking at trying to drive together here. I've been told I've got 5 minutes left, so I'm going to open the floor for any last questions, and then I'm going to draw my summation together and thank everybody. So any last questions, please? I'll give you a couple of minutes to think while I go through my musings, as I can see Ali smiling away.
No, I'm happy to be here as long as needed.
Okay, good. Okay, well, I think for me, this session has been really, really informative. It's showing the development that industry is making, recognizing human behavior in emergency situations. And people don't behave the way you expect. The analogy I often use in this is, if we go to a shopping mall and we park in the cinema car park and the fire alarm goes and we're at the other end of the shopping mall, we're going to try and get back to the car park because that's our route home. Our house keys are probably in there, and we know the way in and the way out. And that's part of this voice voice alert system, is to help you keep you safe. and ask you to exit via the nearest route or the nearest exit because we have an incident, also maintains an element of calm. One of the challenges, we spoke briefly about it in the region, is the multiple languages and multiple dialects, and these systems are able to um, give messages in multiple languages again. So we aren't expecting people to follow like sheep. We're expecting them to listen and understand why they're being directed the same way. So again, that's an intelligent, and not AI, but it's using intelligence to help people make the right decisions. Working alongside the civil defence, the authorities having jurisdiction again, and making sure that we comply is vital. And I see these systems only enhancing life safety in buildings. And we know that the tragedies and the way that rapid fire spread has occurred in recent years, these systems would help people make the right decisions. Evacuation takes many different forms, from the stay in place, the phased evacuation, to the total evacuation. And these systems will help apply the right ones at the right time. So thank you, Ali, for what I think has been a really interesting,
Thank you.
presentation. I'd like to thank Potter Global Technologies for hosting or sponsoring the webinar today, and Fire Middle East for hosting it. Again, it's always a pleasure to be able to sit in the chair and give my musings and my operational head to it all. But most of all, thank you to everybody that's attended. We over 40 on the attendance, which is fantastic, and I hope you've all taken something away from it. I know I have, and I look forward to spending time talking to Ali in the future and sharing our thoughts. So, any
Sure.
last interactions from anybody? I'll close out. Have you got a last statement, Ali?
Thank you, Bob, again. And thanks a lot. It's been an honor and a privilege, to be honest, to present this. I hope it gave you some added value, some useful information to do. In the end, we are in the life safety system, so it's a very important topic to consider. Hopefully, see you soon, and we'll discuss more. Thanks a lot.
I look forward to that. Thank you very much, everybody.